So hello everyone, we are team from Dole Patil College of Engineering and this is our project CubeSat based environmental monitoring system and communication system. So in this project we have followed a CubeSat based architecture and this will provide real-time environmental analysis, real-time dashboard analysis with low cost using IoT and ESP32 devices and Wi-Fi communication. So in this project we have used three nodes. First is our CubeSat node, then second is our urban node, and third is our rural node. So I will explain each node one by one. So this is our CubeSat node. Now this CubeSat follows standard CubeSat measurements 10 by 10 mm, and this is ready to deploy 20 to 30 km above from the ground level using weather balloon. We have already deployed it 20 to 30 km above from the ground and already tested it using LoRa module for the communication. So it has bunch of the sensors. So I will explain each sensor. So this is our ESP32 camera, which will give us camera feed every 2 seconds, every new image every 2 seconds on our live dashboard, and it also stores image locally on the SD card. Next we have BMP280, which is pressure and barometric sensor, which will measure pressure and barometric in the space. Then we have DHT11, which is our temperature and humidity sensor, which will measure temperature and humidity. Then we have GPS module, which will tell live GPS coordinates of the satellite system. Then also we have MPU6050, which is accelerometer, which will measure acceleration and gyroscopic activities of the CubeSat and orientation of the CubeSat. What is the orientation of the CubeSat? And then we have battery pack, which will provide a battery, and we have solar panels, which will give power to the whole system using solar energy. Now, all this we have also have SD card module, which will store all the data locally on the SD card, so we could take it when we recover the whole satellite. Now this is our CubeSat node, which is going to be high in the 20 to 30 kilometers above from the ground level using weather balloon. If we This is now our prototype module. If we made it in a commercial module, then we could launch this in the space. Now then we have urban node. Now urban node contains DHT11 as a temperature and humidity sensor. We are going to place the urban node in metropolis cities, in urban areas, which will going to measure the urban parameters in that particular area or in that particular city. Now it has DHT11 temperature and humidity sensor, which will measure temperature and humidity. MQ135 as an air pollution sensor, which will measure AQI and air quality in that city. And then this is powered by the battery pack, and it has ESP32 as a main microcontroller. Now this will measure these two parameters. Now then we have rural node. In rural node we have bunch of parameters. First is DHT11 temperature and humidity sensor, which is again going to measure temperature and humidity in rural areas. We are going to plant this rural node in villages, in rural areas, to measure its parameter in that village or in that rural area. Now then we have water level sensor, which will tell the water level in nearby water reservoir like lake, pond, then well or river. It could tell the water scarcity, means if water is low, then we will get low level alert, and if water is high, then we will get flood alert. So this could be also act as a disaster management. Then we have soil moisture sensor, which will measure the soil moisture level in that whole village. Now if the soil moisture level gets dry, then we will get alert that soil moisture level is dry. If it's sufficient, then we will could send alert to the farmers that it is the best time to plant the tree, plantation and all. Then we have vibration sensor. Now if there is any seismic activity in rural area or in villages, then we could measure this seismic activity and give alerts to the people using this vibration sensor. Now it is also ESP32. Now what these both nodes do is that this urban node send their data to the CubeSat. This rural node send their data to the CubeSat. Means this both node send their data to the CubeSat, and CubeSat send its own data, its own sensor data, and this two nodes data to our web dashboard. Now this all data is sent to the web dashboard, and our CubeSat is the main server, and this is our main server which will send data. Now this acts like as a real satellite based communication system, and we have our own independent communication system. So this communication system doesn't rely on any other factor like internet, or if there is any internet crisis, if there is any disaster management. So in that our system will based on its own individual system. Now here we have web dashboard. On this web dashboard, we could see temperature, CubeSat node data, rural node data, and urban node data. Now we could see temperature, humidity, pressure, all the CubeSat based data on the axle orientation of the CubeSat and GPS coordinate of the CubeSat in the CubeSat node. In rural node we could see the what vibration level, water level, then soil moisture, then temperature and humidity. In urban node we could see the air quality, humidity and temperature. So all this data is being monitored on the CubeSat. All this data get refreshes every 2 seconds, and we have also live camera feed, which is not being currently showed here. uh, so this is our whole CubeSat based monitoring system, and that's it. Thank you very much.